right? So we need these two libraries. So let's go ahead and set that up. So we're going to use the bank example. And what we're going to do in R is a couple of things. One is we're going to run a regular logistic regression, because it's full model, and then we will do stepwise. Okay, remember, we did stepwise in regular regression in chapter 6. So there is a equivalent here for logistic regression. Okay. So those are the two things that we will do. And let's go ahead and read the data in. Okay. Bank.df. Okay. CSV. Okay. So now we have the bank data in, and let's do a partition. Well, before partition, we want to set up the education as a factor. Okay, so right now, you see that, well, we need to remove ID and zip code. We don't want those. Then education is 1, 2, or 3. There are 3 levels of education. So even though they are coded as numbers, they are actually that variable is a factor variable. We need dummy variables for that when we run the regression analysis. And this is a model-based analysis, so we can't have 3 dummy variables when you have 3 values. We can only have 2 dummy variables. All of that Caret will take care, as long as we identify that column as a factor predictor. So we have to do 2 things. We have to get rid of these 2 columns, and then we have to define education as a factor. Okay, so let's do this. Bank.df is we do subset. Okay, bank.df. Then we do select, and we really want to deselect. So we do -c ID. Well, let's make sure that I did zip dot code. So ID, both are ID should be that. Okay, and then bank.df education. Okay, we can do as factor, in which case it will just be converted into a factor, or we can do factor instead of as factor, in which case we can specify, we can give names for the different levels. So bank.df education. Okay, so that's the one, and then we can say levels equal to, and here we have the levels are what, 1, 2, and 3 for education. So we say 1, 2, 3. Okay, and then we can give labels for those levels. Okay, so labels equal to again undergraduate, graduate, and professional. Okay, so now we have, okay, so education is recoded, ID and zip code are gone. Okay. Next we will set up the partition. Set seed 1. Okay. Train rows is create data partition. Okay. Bank.df personal loan. P equal to, say we want 60% train. List equal to false. And then train.df is bank.df train rows, and then valid.df bank the balance. Okay, I need the bank df there. All right, so now we have the data set up, and then if you want to run logistics regression, it's GLM. We have done this before without getting into all the details. So personal dot loan. Okay. All the variables we've already gotten rid of the columns that we didn't want, and so data equal to train dot df. Then you say family equal to binomial. Okay. Let's save this as legit.reg. Summary of. Okay. So that's the regular code that will generate our okay, so this gives you the formula. Okay, so here are the coefficients. And remember, if you do e to the power of this coefficient, you're going to get odds ratio. Okay. So here are the significance and all that. Okay. Now we can use this legit.reg to predict. Okay, if you use predict legit.reg data equal to valid data, then you'll get the predictions for the validate data set. And then with that data set, you can develop your confusion matrix. We have done that many, many times. Then if you use predict with a response equal to probability, prob, then you get the probabilities. And you can use those probabilities to build ROC chart.